good evening to all of you. Last time we were having a discussion about CPM. We took some questions from CPM. Today we're going to talk about PERT, okay, Program Evaluation Review Technique. All right, now let's discuss when do we use PERT and when do we use CPM, all right? So, okay, fine. Okay, then according to your understanding, what do you think, when do we or when should we use CPM? Yes? Hello? So yeah, what we did in CPM, I'm going to just recap it till people rush into to this course, this free course on YouTube. So firstly, we talked about various times, all right? Forward pass, backward pass, various times. We talked about earliest start time, earliest finish time, latest start, latest finish time. We talked about them, right? And we also talked about float or slack. A very good evening to you, Akash, okay, and a very good evening to Raj, Anurag. I welcome you here to another session, and today we are going to take PERT, all right? So CPM, we said that CPM is deterministic. What does that mean, deterministic? Deterministic. What is the meaning of deterministic? We have had a discussion about this, okay? Okay, Akash. CPM is used to calculate project duration. Mohammed says, Akash also says project duration. PERT also we calculate project duration, right? We can calculate project duration. So what is the meaning of deterministic? Just tell me, okay? What do you think about deterministic? Yeah, so answers out there, okay? Just guys, just make it interactive session, all right? Just don't think that if you're wrong or right. Just whatever comes to your mind, just post in there, okay? Yeah. So, so what is deterministic? What is the meaning of deterministic? Come on. What is the meaning of deterministic? What do you think it is? It is nothing but you're sure about. Sure. Let's say you're trying to make buildings, all right, and you have made thousands of buildings. Okay, you have made thousands of buildings, and you know exactly that one activity takes, let's say, A activity takes 10 days. Okay, B activity takes 12 days. You're sure about this. That's what is the meaning of deterministic. All right? Yeah, that's what is CPM. You're sure about it because you have already made thousands of buildings. All right? Yes? Is that it? Okay, fine. So that is what is the meaning of deterministic. But what if, let's say, you are a new builder and you want to make a new building? Then what? Then what? You don't know that A activity takes 10 days. You don't know B activity takes 12 days. So we always talk in terms of probabilities, all right? So we say that probabilistic models, okay, because we are not sure, all right? We are not sure, that's why. So for that we do PERT, Program Evaluation Review Technique, and we talk in terms of probabilities, all right? That, the A activity can be done in 10 days with, let's say, with 95% probability. This is what we say in PERT. Let's say, all right? Yeah. Is that good? Yes? Okay. Now, I have given you the context of what is PERT and what is CPM, right? And they are different. And in PERT, we talk about 3 times, okay? In CPM, we had just 1 time because we were sure about it. Is that it? Yes? Here, we have 3 times: optimistic time, most likely time, and pessimistic time, all right? So, who is an optimist? Can you please tell me what is the meaning of optimistic? What is the meaning of pessimistic, all right? Yeah, Otton, good evening. Jafar, a very good evening, okay? Chalo. And let me tell you, Sangeeta, if you're asking what is the meaning of CPM, maybe that you have not watched our previous videos, all right? You get back to those videos, and then only you will be able to understand the context of CPM. All right. So what is the meaning of optimistic? Can you please tell me? Yeah, Manish, good evening. A very good evening to you. Positive thinking is optimistic. All right. Okay. Who is an optimist and who is a pessimist? Can you please tell me? Just write in there. Manish Mishra says positive thinking is optimistic. All right. Okay, fine. Okay, good. At least he replied. And there's nothing right or wrong here, guys. Okay. Okay, so optimistic is who? Who is optimistic? Optimistic is one who says that I can do it. Pessimistic is someone who says that no, nah, I cannot do it. मेरे बस की बात नहीं है, right? It's kind of that, right? That's why you always say that optimistic time is the minimum. If you see this, optimistic time is the minimum. All right? And pessimistic says that no, I cannot do it, yaar. This is beyond me, all right? That's why pessimistic time is maximum, because he says that, okay, I will be able to do this activity in 7 days, because he's pessimistic, he is doubtful. That is what is the meaning of pessimistic, all right? Optimistic means he is hopeful. That's why he says that I'm going to do it in 1 day. So I hope I have given you the context, and most likely is in between these two, or maybe same as optimistic, as you can see here, right? Generally he is in between optimistic and pessimistic. He says that okay, in 3 days I'm going to do activity 1, 2. Okay, that's all. Is that it? Yes. Yes, just type in I if you understood it, and so that we can move forward. Okay, we can sail forward. We need not repeat everything. Okay, so the first thing, this is given to you, and PERT, whenever we are talking about PERT, you'll be given 3 times over here like this: pessimistic time, optimistic time, and most likely time. Is that it? Yes. So should we move ahead? Just type in I if you want to move ahead. All right. Yeah, Praveen, your chairs are visible, okay, but yeah, a bit of interference because of this recording camera over here. Okay, yeah, so let's try to make this, okay. So what is this? So what is this? So activity I to J, so these are the even numbers, all right. So what it says is, okay, there's an activity from event 1 to 2. That's what it says. This is 2. 1, 2. Okay. Okay, Hannah. Hannah, actually, yeah, you can be here. Okay. So chats, actually, it's because of the camera that the chats are not getting noticed. All right. So maybe I can call someone. Okay, fine. So 1, 2 is an activity, all right. This is what it tells us. And 1, 3 is also an activity. 1, 3. Then again 1, 4 is an activity, all right. Is it good? That's what it says. Okay. The chat app, my chat दिख नहीं रहा है. Okay. Okay, so yeah, I apologize. Okay, so yeah, this is fine. This is fine. Okay, good. Okay, thanks. Yeah, so J, in spite of 1 time duration, there are 3 time durations. Yes, in PERT, because we are not very much sure in PERT. Okay, we are just talking about probabilities. We are talking about chances out there. Okay, Yes? So there are 3 times. That's why there are 3 times out here. And it also depends on the type of distribution that we are going to use, all right? So yes, 3 times are there. So we're just going to plot this. 2, 5 is also an activity, 2, 5. Okay, then 3, 5 is an activity. So I'm going to just join it like this. And 4, 6 is an activity. So I'm going to say that, okay, 4, 6 and 5, 6 is also an activity. Is it good? Is it good? Yes? Yeah. So, yes. Hello, you there? Is this clear to you? We just joined these nodes. 1, 2, 2 I joined. 1, 2. 1, 3 I joined, right? 1, 3. Similarly, 1, 4 I have joined. And 2, 5 I have joined. All of these, right? So I hope that you are getting this, all right? Okay, fine. So Muhammad says that critical path is 1, 3, 5, 6. So the question is that which one of these times must be taken over here? Okay, yeah. So it's good that you are still there. Okay, J has been really consistent. Okay, so fine. So what we have is that's an average time we like to calculate over here. That is given by T optimistic time plus 4 times most likely time plus T pessimistic or pessimistic time upon 6. That is the average time to complete a project. Why average? Why average? Yeah, exactly, Mayan. You're right. Okay, I is the starting of activity, J is end of activity. Yes, yes. So why average time? Average time, whenever we are not sure about anything, we say, okay, let's take average. Right. That's why we are calculating average time here. All right. Yes. Is that it? Average is really very important, right? The mean is really very important in probability. So average time of completion of an activity is given by T0 plus T plus 4 Tm upon 6. Okay. Now, and also, okay, before this, the variance of an activity. Okay, I guessed correctly. Okay, Jay, is good that if you could guess it very correctly. Tp minus To upon 6 whole square. This is the variance of an activity, all right? Variance is sigma square, where sigma is nothing but standard deviation. Yeah, Mohammed, you're right, okay? Expected time is nothing but T0 plus 4 Tm plus Tp upon 6. It's good, all right, good. Now, what I want you to do is, I want you to calculate this average time or expected time for each one of these activities. Let's say for 1, 2, how much are you getting average time? All right, 2, 5, how much are you getting the average time? You already have this. Optimistic is nothing but To, most likely is Tm, pessimistic is Tp. Can you please just tell me all of these times? Okay, just take your time, guys. Okay, why it's not normal average? What is the meaning of normal average, J? What is the meaning of normal average? So can you please elaborate? Okay, so Muhammad says that Muhammad has already calculated it. Okay, good, Muhammad, that you're fast. Okay, I like that. Good. So others, please calculate this time for each and every activity. This time. And tell me how much are you getting that, all right? It's fine, Damdar, okay? Duration is yeah, Anurag, actually, these distributions are really, they are just guesses, all right? Okay, they're just guesses. So once you take up mathematics, all right, engineering mathematics, then we will talk about why do we get distribution the way we get them, all right? Okay, so it's kind of that, and we are just trying to guess the time of an activity. All right, then we say that, okay, beta distribution is almost symmetric, it is unimodal, means it just has one mode, and it's also is positive. That's why they said, okay, let's take beta distribution, and it's an approximation, let me tell you, Anurag Srivastava, right? Is that it? Yes. Mayank, this is in accordance with beta distribution, all right? Beta distribution, that's all. Okay? Yeah, so Kisna, okay, fine. So please tell me all these 1, 2, 1, 3, 1, 4, 2, 5, 3, 5, 4, 6, 5, 6, and all. So he said that 2, 4, 3, 1, 6, 5, 7, all right. So he said that 1, 2, we are getting 2. Okay, 2 days. 1, 3, we are getting how much? 1, 3, he says 4, all right. 1, 3, we are getting 4, then 1, 4, we are getting at 3, okay. 2, 5, then 1, 4, 2, 5, yes. 2, 5, you would be getting 1, right? Yes, should be 1. You just need to plug in these values over here, right? And 3, 5 should be 6, 5, 7, all right. So 3, 5 is 6, and 4, 6 is 7, all right? Yes? Yeah, 5 and 7, he says. So this is 5 and this is 7. So just plug in these values over here, okay? So, yeah. Is it all right? Is it all right? Yes? Is it all right? Hello? Okay, fine. So you can plug in these values, and actually you will read it in mathematics, okay, Mayank. You will read it in mathematics. Expectation is the mean value. Mean value of a random variable is given something like this, okay, into x into fx dx. So this is the theory behind the mean, whatever mean we are seeing over here, all right? So let me get back. Yeah. This one. All right, so that thing, actually you'll be reading it in mathematics. How do we come up with these things and variances and all right? So don't worry about that. Okay? Okay, so is it confirmed like this? So whatever you do, you are going to calculate this and use these expected or average number of days for calculations. All right, now can you please tell me what is the project duration from here? Till then I'm going to just erase them. Just tell me what is the project duration. So what it is? What is the project duration over here? See, it's very clear, right? So for project duration, what are you going to do? Yes, Mohammed, Anurag, good. So for project duration, what are you going to do? How you are going to calculate the project duration? Yeah, so what I'm going to do is I'm going to write the paths possible from left to right, from 1 to 6, right? Because 6 is the ending event, right? So we say that, okay, 1, 2, 5, 6 is first path. Second is 1, 3, 5, 6. This is the second path. And when I'm done, please write the total number of days in path 1, 2, and 3. Just write it in screen, all right? The third one is going to be 1, 4, and 6. So 1, 2, 5, 6, how much time is it going to take? Yes, it's going to take 10 days. 1, 2, 5, 6. 1, 3, 5, 6, 4 plus 6 plus 7. It's going to take 17 days, all right? And this is going to 1, 4, 6 is going to take 8 days. So the project duration is the maximum of all of them, and this is the critical path, sorry. So 1, 3, 5, 6. Let me use another color for this. is the critical path. This is what we say. So 17 days, yes, good. Yeah, good, Jay. Good that you're involved, okay? So 17 days is the time of the project duration, all right? Now, let's do, okay, fine. So can you please find, now can you please find standard deviation of project? Can you please think about this? How would you find standard deviation of project, all right? Can you please think about this? Yeah, Raghunath L, hi, I'm good. How are you doing? I hope your heat and mass transfer is going really impeccable. Okay, so can you please tell me, okay, standard deviation of project? Now, let me ask you a question before that. What is this 17? We said that project duration time. So, what the kind of time is that? We said that 17 equals to project duration time. What is this time? Project duration time. Project duration time. So, what is the 17? What kind of time is it? Is it the maximum time? Is it the minimum time? Or is it the most likely time? So, that in that sense, I want to ask you. Okay, so just tell me the answers, guys, okay? Rahul Mishra says sum of individual standard deviation, okay. Fine, okay. Okay. Square root CP. What is that square root CP, Nagbhushan? What is the meaning of square root CP? What is CP? I never wrote any CP over here. Okay. Okay, Rahul Mishra. Okay, we'll see that, okay. We'll see that, okay. So what is 17? What is 17? What is 17? Okay, Anurag, let's see, okay, how much you're getting. Standard deviation. Standard deviation is 5. Oh. So what is this time? 17 is the question, right? Because we have calculated it and you must understand whatever we have calculated. Yes, that is project duration. Is it the maximum project duration or the minimum project duration? That's what I want to ask. Let's talk about this, guys, okay? Just hold on, okay? Don't solve questions. Let's understand first. Then only you can think of getting a rank. Without understanding, no, you won't get any rank, all right? So, what do you think? Come on, guys, this is average duration, all right? This is the mean. This is average because we have used TA, right? Average expected time. Okay, that's what it is. It's not max, it's not max. It is the average time. All right, so that's why. See, you can solve the problems, but you know, these simple concepts are missing, guys, okay? So please think about this. Exactly, Jay is right in this, maybe higher or lower than 17. It's most probably 17, so that's what is the meaning of average time, okay? Yes. Is that good? Yes. Now, can you please think about standard deviation of project? So we say that 1356 is, okay, so I'm going to just remove this. All right, and I'm going to say that 1356. So again, I'm going to just remove this and 13. I'm going to note all of these activities, all right? So 13 I have noted because I'm seeing here 13. Then 35 I'm going to note here, 35, and 56 I'm going to note here because a standard deviation of project is nothing but standard deviation of critical path. Okay. So I'm going to repeat it. Standard deviation of project is nothing but standard deviation of critical path. All right. So for this 13, just calculate variance. Okay. So sigma square 1, 3, just calculate it. So that is nothing but TP minus TO upon 6 whole square, right? So 1, 3. So 7 minus 1, that is 6 upon 6 whole square, that is 1. Right? I had given you a formula for that. Yes? Is that it? So sigma square 1, 3 is going to be this, and sigma square 3, 5, sigma square 3, 5 is going to be 14 minus 2, that is 12. 12 upon 6 whole square, that is going to be 4. Yes? Are you able to see this, or should I write in the next page? Is this clear to you guys? I don't think it's clear. Okay, so yeah, so I'm gonna have to rub these. Okay, and we are just going to focus on the critical path, right? So again, I'm going to write it because maybe that you're not able to see this. So sigma square 1, 3 is going to be 7 minus 1, that is 6 upon 6 whole square, according to the formula, right? I had given you a formula for that. Sigma square 3, 5 from here, 3, 5, okay? That's going to be 14 minus 2, that is 12 upon 6 whole square, that is nothing but 4. And sigma square 5, 6 is going to be 15 minus 3, that is 12, and 12 upon 6 whole square, that is 4. I'm going to sum all of them, okay? So 6, so I'm not going to write sigma, so sigma square equals to sum of them, that is 9, so sigma is 3. Standard deviation we say is 3, all right? Yeah. Is that good? Is this correct? Is this correct? I or nigh? I or nigh? Yes. Yes. So always remember that whenever you are being asked to calculate standard deviation, you are required to calculate variance, all right? You just can't add all the standard deviations, okay? It cannot be added, it's kind of that, okay? So if you just add standard deviations of all of these, that's not going to work. It's not 5, it's actually 3, okay? Just keep this in your mind. Is that good? Hello? Yeah, sigma is standard deviation J, okay, I had mentioned it over here. Sigma is nothing but standard deviation. Variance is nothing but standard deviation whole square is variance. Okay? Don't worry about that. We are learning, still learning, and it's okay to make mistakes, all right? J, yeah, but you're good, you're really good. Okay, you're doing good. Yes, okay, Mohammed, Anurag, everyone's doing good, Krishna, okay, but the thing is that, for example, you know, I go to gym and I just go to gym for 15 minutes a day in 1 week. Okay, then how, no matter what I do in gym for 15 minutes, nothing is going to happen to me, all right? Nothing is going to happen to my muscles. If I want results, I have to go to gym almost 4 or 5 days a week, right? At least for 1 hour. So similarly, that is applied to you as well, guys, okay? If you tune in, you are regular here, you're consistent here, then only your mental muscles are going to be developed. Otherwise, no, one day you come, one day you leave, nothing's going to happen, let me tell you, very frankly, all right? Okay, fine. So sigma is nothing but 3, all right? This is what we say. Okay, now we go to the next slide. And okay, so expected project length we have already calculated, okay? Expected project length we have already calculated. Variance of each activity you can find, okay? Variance of each activity can be found out using TP minus TO upon 6 whole square, right? And I think that I have given you context why TP is more than TO. Yes, I've given you real life example of who a pessimist is, who an optimist is. Now you can understand this, right? So TP is always greater than TO. Okay, so yeah, so we have calculated the variance and standard deviation of project length. Okay, now we have to calculate that what is the probability that project will be completed at least 3 weeks earlier than expected. Okay, so this is what we need to calculate. Now please note this, that project here in PERT is normally distributed. We'll talk about this if you take up mathematics, okay, and I'm going to tell you, I'm going to teach mathematics to you as well, all right. So we'll talk about what a distribution is, what a probability distribution is, all right. So yeah, okay. Now a project is normally distributed, all right. So that's what, and why is it normally distributed, we are going to talk about in mathematics. Okay, we'll understand what a normal distribution is and what are other distributions as well. Okay, now this is the mean of normal distribution, right? And we are talking about time over here in x-axis, and y is the frequency, all right? Okay, so this is nothing but 17. This is what we had calculated, okay? 17 average number of days. That's why I'm writing here 17. Is that good? Yes? Hello? Is it good? Just type in I, okay? Just keep on saying I, okay? Otherwise, I'm not going to get if you are getting it or not. So it's really important. Okay. And you have to say I, okay? A-Y-E, I. This is correct. I. This is wrong. Okay. Yeah, good. So what it says is, at least 3 weeks earlier than expected. So we are talking about this. So 3 weeks means 14 we are talking about, right? 3 weeks earlier than expected. Expected is 17. Expected means always average, guys, okay? Wherever you are noticing this word expectation. Expectation is nothing but average, always remember. We'll also talk about this in mathematics, okay? Yes, exactly, Rahul, Pirates of the Caribbean, aye, Captain. Okay, so what it says is 3 weeks earlier than expected. So it's talking about this region. 3 weeks earlier means that we are talking about this region, all right? Yes, agreed, I or an I. Whatever I have drawn over here, do you agree or not? Do you agree or not? So I'm waiting for responses, guys. Okay, just tell me if you agree or not, that's all. Yes, so it's up to here, right? 14, so we are talking about this thing. Right, because it says at least 3 weeks earlier. It can be even, 4 weeks earlier, so it would be 13, right? 5 weeks earlier, it would be 12. So we are talking about this whole region, right? So whenever we are talking about, let's say, normal distribution, this area, you should remember this area gives probability. Gives probability here. Again, this is mathematical. We are going to talk about this in mathematics, all right? So just remember that this area gives probability, okay? Now, there's something called, because it's normally distributed, there's something called Z that is given by x minus mu upon sigma. Okay, this isn't, whenever we are talking about normal distribution, we are going to calculate Z. Okay. So for 3 weeks, it's before 21 days. Before 3 weeks, earlier than expected. Before 3 weeks, no, that would be after 3 weeks, right? J. Before 3 weeks, it's before 21 days. No, that language is not clear, J. Okay, just rephrase your statement, whatever you're trying to convey. Okay, so we always tend to calculate this Z. that is given by x minus mu upon sigma in case of normal distribution. And why? You'll come to know, right? So here x is nothing but 14, mu is nothing but the mean, that is 17, and sigma we have calculated as 3, so it comes out to be -1. Is it good? Is it good? Days or week? 17 is weeks, okay? Don't worry about the unit, okay? So if it's week over here, then certainly there it should have been weeks, all right? Yeah, it's in weeks. Okay, it's in weeks over here. Don't worry about these things, okay? Weeks or days, but yeah, everything is consistent, all right? Okay. Chalo, if I said days, then I'm sorry, but still I'm telling you that don't worry about that, okay? Because concepts are more important than the facts over there. Okay, so how do you calculate this now? Okay, now let me tell you. Okay, there we had time, right? There we have time in x-axis. If we are just trying to convert this into z, okay? So when I wrote z like this, what we are trying to do is, we are trying to convert this time. Here is 17, here is 17, and here is 14. We are just going to convert this into z, and in mean z is nothing but 0, and this point z is -1, right? This is the point of time equals to 14, and this is the point of time 17. Hello, is it clear to you or not, this thing? Because z is nothing but x minus mu upon sigma, right? When x equals to mu, z equals to 0, all right? So z equals to 0 when x is mu. X here is t, all right? Don't get confused by t or x. Is that good? So we are just trying to convert this into z on x-axis. That's all right? And we'll be always doing this whenever we talk about normal distribution. Is that good? Okay, fine, good. Then obviously we have to calculate this area. This area we need to calculate. That is also this area. Both of them are same, all right? Here, both of them are same. Okay. Z is nothing but this Srilata. Okay, Z is given by this. This is called normal variate if you want to note it. Normal variate. Normal variate is Z. Y-axis is nothing but frequency of occurrence, all right? Y-axis is nothing. Y-axis is frequency. How many times? Frequency of occurrence. Frequency of occurrence. It means that let's say you are trying to make this 100 times. Okay, you are trying to do a project 100 times, 100 number of times. So what it means is, in most of the times here, let's say this thing is 50. All right, and most of the times the project takes 17 days. That's why this is 17. Okay, if you are trying to understand this, okay. Yeah. Is that good? Yes. Yeah, movies clip. Okay, fine. Yes, I came there for hypermesh. All right. If you are trying to understand this, so I have made you understood this. All right. If you don't understand this, it's again fine. All right. This is a very heavy stuff, at least for me. All right. Yes. So we are going to calculate this, and okay. And let me tell you that if Z lies in between -1 to 1, then area enclosed is nothing but 68.26%. This you need to remember, right? We have to subtract 1 from 14, so we can get at least 3 weeks earlier than expected. From 14? No, Mohammed. Expected means what? 3 weeks earlier than expected means it's going to be 14, all right? 3 weeks earlier than expected. Expected is 17 days, all right? Mohammed, I'm replying to you. Expected is nothing but 17 days, right? That's an average. Expected means average. So 3 weeks earlier than expected means that, okay, 14 is the maximum limit that we're getting. Is that good? Yes, Movies Cliff for you. It's good name, and it's also good to see you again, all right? Is that good? Is it good? At least 3 weeks, it says. At least it says, okay, Mohammed. So that's in the word. So at least means that, 14 should also be included in that. At least it has to be 14. Is that good? Okay, fine. So area is nothing but, we say that this area is, which area? This you need to remember, right? This is, it will always be useful to you. This you need to remember, all right? Yes, so this area is given to you as 68.26%. Okay, can you find this area? Can you find this area is the question. Yes, you can. Why? Because this total area is 100%, right? Yes? Yes or no? This total area is nothing but 100%. So can you please find this area? And let me tell you that if this area is X over here, this area is also X, because normal distribution is symmetric. Yes, Shivam, actually, yes, it is a free course for this area, but yes, we have paid courses as well. All right. Okay. Yes, we have paid courses as well. So you can tune in if you want to join in. Okay. Shivam Srivastava. Okay. Is that good? Yes, Rajesh, it's always true if Z is lying in between -1 to 1. It's always true, all right? So let's say this is X, this is also X, and that is 68.26. So 2X plus 68.26 equals to 100%. Now please tell me what is the value of X by this. What is the value of X? Just tell me, okay, using this. Yes, Hare Krishna, how are you doing? Yes, Hare Krishna, I think that you're doing good, okay, yes. Is it 15.87? Okay, so then we say that this is 15.87. And mind you that this is in percentage, all right? Everything is in percentage. Yes? So probability equals to nothing but 0.1587. So that's your answer, all right? Is it good? Yes? Probability cannot be greater than 1, right? So we just converted this percentage into probability, that's all. Is it good? Hello? Is it good? Hello? You there? Aye, good, yes. So this is how we solve it, and this is how these questions are solved, guys. And yes, someone was asking about, how do we calculate the mean? Mean is calculated like this. Mean of X is calculated something like that. And yes, okay, that's what it means. J, it means that the probability of project. Okay, let me read the statement. the probability that the project will be completed at least 3 weeks earlier is nothing but how much was that? 0.1587. That's what it means, right? That's what it means, okay? That's what it is. Work can be done earlier by 15%. Then you can calculate this percentages and all. Okay, if you want to calculate the percentage, you can calculate the percentage. 3 upon 17 into 100. That's going to be the percentage. Okay, J, I'm talking to you. Okay. And yes, Hare Krishna, it's good that you were comfortable in industrial engineering, but yes, just keep on revising. All right, mark my words, go back, revise stuff, and thank you, Hare Krishna, for those nice comments. All right, and I'll see you again, okay, because we are going to meet shortly for mathematics, I guess. Hare Krishna, I'm talking to you, okay. So that's what it means, okay. Now tomorrow again we are going to meet, okay, and tomorrow again we are going to meet same time, 9 to 10. We'll take more questions like this, but mostly questions come like this in the same pattern, okay. ESE prelims, I think it should be 140, Rahul Mishra. This is what I remember, all right. ESE prelims cutoff might be 140. This is what people said here, experts said over here, okay. Yes, Hare Krishna, please leave and study a lot, okay, and I'm going to catch you soon in mathematics, okay. Yes, for different Z values, there will be different area value, obviously, yes, okay. If, let's say, this is -1, this is 1, okay, and let's say this is -2 and this is +2. So obviously Z, when it lies in between -2 to 2, the area enclosed is going to be more, right? And in that case it comes out to be around 95.45%, okay. And when it's -3 to 3, area comes out to be around 99.97%. So if you can remember all of these, it will be good to you, okay. Yeah, Jay, actually, when we'll be doing mathematics, certainly we'll talk about probability and all, but yes, always when you go back, you can learn probability, all right. It's very easy, okay. So Mayank, I think I have replied to you, and I'll see you again tomorrow, okay. Then keep on believing, guys, keep on being happy, keep on being hopeful, be an optimist. Not in take good sleep. Sleep is really important for rejuvenation and energy. I'm going to see you again tomorrow, same time. Bye bye.